What's up mga ka-chair? It's Dale here and I'm back with another chemical engineering lesson, but this time I will be teaching the students, fourth year students of University of Santo Tomas, chemical engineering students. So one of their officers approached me and requested me to do this lecture in biochemical engineering. So for those who haven't known me yet, so those don't know me yet, so I will introduce myself later, so for this is for just not the regular viewers of this channel, so without further ado, so let's begin with this lecture. So I will be doing this the first time, the biochemical engineering. Now let's begin with this lesson. Okay, so this is for the academic reinforcement sessions. So they have this, so I really commend their Chemical Engineering Society of UST for doing this for the advanced lessons for their fourth year students. So yeah, I really commend that. I really like this idea, and also I guess the the JPCHE in our school will also do this, so for the betterment of also our fourth year students in our school. Yeah, I hope they will get this idea from them. Okay, now let's begin. So for this lecture, what we will discuss, so we will just review microbiology and biochemistry, so what are the wonders wonders of this field, diba? And also for enzyme kinetics. So the enzyme kinetics is really the heart of what we are studying today. We will discuss simple enzyme kinetics and Michaelis-Menten kinetics. So all of the other one will be included here, maybe in passing. Okay, so for those who don't know me, for the first time viewers of this channel, I will introduce myself again. Okay, so I'm Day Lopez, so I'm a graduate, so Che and SO. Okay, so I'm a former GPCHE, so Junior Philippine Institute of Chemical Engineers, so XU, COMELEC Chairman, and XU ACES, ELECOM Commissioner, ELECOM Chief Legal Counsel, XU Central Student Government, SSG, ELECOM. So as you can see, I all my extracurricular activities in college were in elections, so I really love holding elections. Okay, so I'm also a former legal student counsel of the integrated bar of this Central Student Government of Xavier University. So it's like our attorney, so I'm like a student attorney at that time, and also I graduated last 2020 in Xavier University, Ateneo de Cagayan, and also I'm currently an area representative for North Mindanao of the Philippine Institute of Chemical Engineers, a Young Engineer section, and also I am a qualified safety officer too. Okay, so I have a Bosch and a Kosh. Okay, so yeah, that's basically who I am today. So now let's begin with our microbiology and biochemistry. So one of the first that comes into our mind is this, diba? What is biochemical engineering? So if biochemical engineering is a branch of chemical engineering which applies technological advancements to biological materials, diba? And also will combine knowledge of biology, chemistry, and engineering to create products from raw materials. So just so I will show you these advancements in technology, na chemical engineers really have a big part in developing these materials that really help us today. So first we're gonna learn is the review na lang siya, no? So we have taken up the biology siguro in our high school siguro. If you have I really think that you have taken up the Central Dogma, di ba? So in our cells, di ba? In our cells, we have our nucleus, and inside the nucleus, we have the DNA. So the DNA is the book, di ba? It contains all the information of our life, di ba? And our genetics, di ba? And our genetic code, what our color of our hair, our eyes, di ba? And everything, ba? How tall we are, siguro, no? So if you can remember, di ba? So in this diagram, di ba? So we have our DNA, and then the DNA will be transcribed, di ba? So it will undergo transcription by the DNA polymerase, di ba? And the direction is spinning from 5 to 3, so 5 3 prime, di ba? So you have the DNA polymerase that will untangle the double helix, di ba? And then it will copy, di ba? Kapihon niya, copy, and then out of that copy, you will have the mRNA now, di ba? The mRNA, or the messenger RNA, di ba? And then after that, this mRNA will go out of the nucleus, di ba? And then it will be sent to the ribosomes, yeah? And ribosomes will translate it, di ba? And then after that, translating it, di ba? It will produce a polypeptide chain or a protein, di ba? So you have this AUG, AUC, UCG, di ba? Or A, so A, and U, uracil, di ba? A, adenine, G, guanine, C, cytosine, di ba? U, uracil. Okay? So yeah, that's how it that's how. And then you have your start codons, really the most common start codons, the AUG, di ba? And then you have your stop codons, UAA. So if you can remember, di ba, the stop codons, this is how I remember this. So wag uga. If you're Bisaya, so you have this is funny. This is funny part. Okay, so then this really miracle, no karon, it really sped up the production of vaccines, diba? Of the approval of vaccines. So usually the vaccines, the development of vaccines from the creation until the FDA approval takes 5 to 10 years, but now it only took 1 year, diba? So yeah, so mRNA vaccines, diba? We were able to create mRNA vaccines. So before, we used to culture, diba? Weakened viruses in the labs, and then it will be so mass produced, diba? And then it will be, the process takes very long. But now, diba? You use now mRNA, and then so we copy a certain code from the virus, diba? Virus, and then that genetic code of the virus produces the virus spike, no? So then that mRNA, diba? And then that mRNA now, diba? So it will be made into a vaccine, diba? And then inject na rin sa atua, diba? And then so packaged into a nanoparticle, diba? The vaccine, which can deliver the mRNA to immune cells, and then that vaccine na dayon, it will go into the cell, diba? And then the cell of our body now does the job of producing those virus spike proteins, and then our antibodies now will be trained to fight those. So that's that's really a wonder for me. No, I'm really mesmerized by that because you know, it's really an advancement of technology because it's the process now is being very fast, diba? So more lives will be saved, no? They will not have to uh, wait for 5 to 10 years for FDA to approve the vaccines, no? So one of the examples of mRNA vaccines is the uh, Pfizer, di ba? And BioNTech, di ba? And then we have another kind of vaccine, that is the COVID vaccine that we are um, um, it's in the circulation and being used by our government to inject, no? To vaccinate our especially the A3, diba? So the DNA vaccines, diba? So how this works is that instead of using mRNA, they use DNA, and then what they use as a vector, no, or as a carrier of this virus DNA is the adenovirus na vector, diba? So and then it will infect, diba? It will infect. This it's not really dangerous, no, virus, no, but it will do the same job of infecting the cell, diba? And then that cell will reproduce the virus, diba? And then the virus spike proteins gapon, spike proteins lang din the virus itself, but the information or the genetic code is being carried by the adenovirus vector, and that genetic code is the virus spike protein, and then it will infect a healthy cell, and then that healthy cell will produce a spike proteins, di ba? And then the immune system will do its job, di ba? So now, the downside of this is our cells can build a resistance to this um, type of vaccine, diba? Because it's a virus, diba? So that's why uh, these kinds of vaccine, diba? It's only administered once, diba? For example, Janssen vaccine. So it's only administered once. There's no second dose because this is what I only learned, you know, and it's what I've inferred from the data that because there will not be there's no need for a second dose because the body might build up resistance, you know, to this kind of vaccine. Okay, so there are downsides to both of mRNA and DNA vaccine. So enough for that. So I've explained mRNA and DNA vaccines, no? So next is the other valuable products, no? For example, what you have, no? You have acetone, diba? And butanol, diba? Which is really as a nail polish, diba? So what is being used here is the Clostridium acetobutylicum na bacteria, diba? And then it's used to produce acetone and butanol, no? Other is the wine, diba? Wine and bread, diba? So it's being produced by the Saccharomyces cerevisiae microorganism, diba? So yeah, ethanol, so kung sa wine, but in the bread, the most important there is the CO2 because it makes the bread grow, diba? The butter grow. And then lastly is the no, this is a Saccharomyces cerevisiae, no? But it's lactobacillus na siya, lactobacillus. Lactobacillus group of microorganisms, no? And then what they produce is the lactic acid. So what is the most important here, diba? Lactic acid. So feminine washes, diba? Because feminine washes, the feminine area is slightly acidic, no? So you can't really wash it with harsh na soap, because it will irritate the private parts. So you need to have a slightly acidic feminine wash, so to for also to care the private parts. So yeah, that's why we have lactacid. And also our favorite drink, ni Yakult, para sa chan, di ba? So yeah, that's what uh, the some of the examples of um, some of the examples of uh, part the contributions of the biochemical engineering to society, di ba? And the contributions of chemical engineers here is really big, because how do you mass produce these products, if you don't have chemical engineers? So that's one contribution of chemical engineers. So think of a household item in your house. There is a chemical engineer at work. Okay. Okay, so now let's move on to the most awaited part, so the enzyme kinetics. So enzyme kinetics. So we will be talking about simple enzyme kinetics and the Michaelis-Menten kinetics. Okay, so what are enzymes? So enzymes are biological catalysts that are protein molecules in nature. Yeah. So they are, if you think of a chemical reaction, diba? If a chemical reaction has a catalyst, diba, to hasten the reaction, we also have biological catalysts to hasten the reaction, biological reactions in our body. Okay, so it is produced by living cells and are absolutely essential as catalysts in biochemical reactions. And also, they catalyze the making and breaking of chemical bonds. Okay, so we have long chains. Diba? For example, if we eat a bread, diba? So which is starchy, diba? So we can't consume or we can't absorb starch as it is. So we have to break it down to simpler molecules, diba? Like so we have amylose and amylopectin, diba, in starch. So we have to break that down to simple molecules like glucose that can readily be absorbed by our body. Okay, so we have, and it increases the rate of reaction without themselves undergoing permanent chemical changes. Okay, so that's really an essential part of the being a catalyst, so not being changed in the reaction. Okay, so examples, diba? Examples of catalysts and their catalyzed, examples of enzymes and their catalyzed reactions. Diba? So renin is the curdling of milk to start cheese making process. And then you have pepsin, hydrolyzes proteins at acidic pH, and trypsin, hydrolyzes proteins at mild alkaline pH. So you have the both sides of the pH spectrum. You have the basic and you have the acidic. Okay, so renin is, I think this is mostly found kung baby. So you have, because they don't have they only consume milk from the mother, so they have to have more renin, okay, in their stomach, because they have to break down the milk molecules. Okay, so yan. Okay, so another mga important mga enzymes in our body, we have the alpha amylase. So this is what I have mentioned earlier. It's the starch. So it breaks down into glucose, maltose, and other oligosaccharides that can be readily absorbed by our body, because starch cannot be absorbed by our body, okay, as it is. Okay, so it needs to be broken down. Okay, lactase, diba? Lactase, if you don't have this, if this is not functioning well, then you have lactose intolerance, diba? So if you drink milk, if you are lactose intolerant, if you're lactose intolerant, you lack the ability to break down lactose into glucose and galactose, diba? So that's why you frequently go to the CR, okay? And then alcohol dehydrogenase for our friends who are into drinking, diba? Alcohol. So I know this also because my final project in 50 year is making wine. Okay, so we have this alcohol dehydrogenase, no? So if you have this, if you drink, diba? So ethanol must be broken down, diba? And then it must be disposed by our body because our body doesn't need it, so it has to be eliminated from the body. So what the body does is that ethanol will be converted to acetaldehyde. For example, if you have C2H5OH, di ba? So it will be transformed to kuan na lang, C2H5O, di ba? So double bond O, mahimo siyang aldehyde, di ba? And then that aldehyde, di ba? So if you remember, if you have this preservative, di ba, called formalin or formaldehyde, so it's similar to that structure. So what do you expect, no? So it's poison in our body. So acetaldehyde is poison in our body, so it needs to be broken down further and eliminated by our body. So what this does is it needs another enzyme which is called the aldehydrogenase, diba? So it transforms the acetaldehyde to carboxylic acid or the acetic acid, diba? Or acetate, diba? So instead of being a formal acetaldehyde na sa inyong body, so you now have acetic acid or you have suka, diba? In our body now. So one characteristic of this, if you don't have this functioning aldehyde dehydrogenase, if you are familiar with Asian flush, diba? So mamula sila. So if they drink alcohol, they turn red, diba? Their eyes will be bloodshot. That's not an indicator of drunkenness, but it's the body's way of telling that you are in danger because you are consuming poison, diba? This is acetaldehyde. So that's how your body reacts. It's not a sign of drunkenness, okay? So it's the body's way of telling you that you are in danger because you are consuming alcohol, and then alcohol, your body does not have this functioning well to convert it to acetic acid and then eventually eliminated by your body. Okay? Yes, so now enough of that. So let's go to the calculation part of this, no, this video. Okay, so we have the simple enzyme kinetics, diba? So this is just simple, diba? You have your substrate, diba? You have your substrate, and then it is catalyzed by your enzyme, and then it will be transformed into product. So how does this translate in practice? Okay, so you have your rate, diba? So you have your rate. So for example, you have your rate here of the substrate being consumed, diba? So you have d CS over dt, diba? And also rate of your product being formed is just dCp, diba? dt, just remove the negative sign. Okay, so how do we do this, diba? If you have let's interpret this graph. Okay, so as time goes by, okay, time goes on, yeah. So the product, you change the product and say substrate concentrations with respect to time. So your substrate will decrease and then your product will increase. So what does this follow, diba? So we have our we have zero order and first order, but we have orders of reaction, diba? So how is this gonna play out, no? So kung zero order, you have zero order. Zero order. So I assume that you have undergone this in your chemical reaction engineering, no? Correct? Okay, so this is really your knowledge that that you have gained in that subject will be really important here in interpreting these graphs. Okay, so if you have a zero order reaction, so for example, you have BCS then BP, diba? And then this is just proportional, okay? So K, okay? So you have that. And then let's integrate that, diba? So BCS, KBP, diba? And then you have integrate that, diba? So this CSO CS, then you have 0 to P. Okay, so if we integrate that, we have a CS, then CSO, diba? And then you have KP. Okay, so if we transform that, na siya CSO minus KP. Okay, so that's the equation, no, for the zero order. So how about for the first order? Okay, so let me write it here. So first order. Okay, first order. So you have RS. So it is proportional to the amount, no? If we say it is the rate of depletion of your substrate is proportional to the amount, diba, of the substrate. So that's how it is interpreted. Okay, so you have BCS, you have CS na, and then let's integrate from CSO to CS, no, and then you have KBP. So same, integrate from 0 to P, yeah? And then you will have ln CS over CSO, negative KT. Okay, so I just for easier, no, integration, so you have to just transfer the negative sign to the other side. Okay, and then you have just multiply this by the exponential form, no, katong E. So EXP, then you will have now your CS. So ako na lang ibalhin siya sa PCAS, so CSO, then EKP. Okay? Yan. Okay, so why did I derive this? Because this is important in interpreting this graph. Okay? So let's interpret this graph. Okay? So you have at the reaction, so at the first, so if, as you can see, at this point, no, at this point, so let me change color. So at this point, the reaction rate is proportional, diba? So the reaction rate is proportional to the substrate concentration, no? This is the first order na reaction, and when the substrate concentration is in the low range, diba? So in this range, no, the rate of the reaction rate is proportional to the substrate concentration. That is a first order. Okay, so as you can notice, diba, as it goes on, it is not proportional to the rate is not proportional to the substrate concentration anymore, no? So as no matter how big this is, no, the rate of reaction approaches the maximum rate. Okay, so it will not increase anymore. So this type of reaction is similar, no, to a zero order reaction, which, as you can see, wala na ang rate, diba? It does not depend on the rate, does not depend on the substrate concentration anymore, whereas you have your first order that really signifies that its need, or the proportionality is needed, is exhibited in the lower concentration. Okay, why is that important? Because the maximum okay, so that's it. That's the explanation of this graph. Okay, so now we will go to our let me delete na lang, no? So how do we combine what we have seen, no, ganina sa ato ang derivation. So this is from the book. So this is how they modeled the reaction, no? This graph. So this is the model of this graph. Okay, so this is that. Okay, and then you have your Km. Km is just a constant, no, for statistics for an enzyme, and then our max is also unit for an enzyme. Okay, so you have this model. So this is a lock and key model. So you have this, this is what they have theorized that the reaction will look like, diba? But there is another so there is another model for this. So it's called the induced fit method. Okay, so for example, if this is a lock and key theory, diba? So it theorizes or it posits that the enzyme, so this is the enzyme, this is the enzyme, and then this is the substrate. So it must fit perfectly like a key to a lock, diba? So that's but in the induced fit, so whatever the shape of the substrate, the enzyme will induce, diba? So it will make its way na ma-fit siya in a substrate. Okay, so ang enzyme ang mag-adjust. Okay, enzyme ang mag-adjust for the substrate, unlike in this lock and key theory. So it must be fit, no? So neither one will have to adjust because they are fit for each other. So sa induced fit is mas realistic because yung isa may mag-adjust talaga sa isa. Okay, so how is this being modeled in a mathematical or in a chemical reaction, no? So you have your substrate, and then you have your enzyme, diba? So enzyme, and then remember that this is a two-way reaction, no? Because it has to have has to be in equilibrium. Okay, so you have your constant 1, your constant 2, and then you will form a complex. Okay, so this is a complex, diba? This is called a complex siya. This is a complex, so ES. So and then this complex, diba, will transform into products, and then the enzyme will remain unchanged. Okay, so that's the simplification, or the gist of the enzyme kinetics. Okay, so that's how it's just like a chemical reaction, but it just happens in our body. So inside of catalysts we have enzymes. Okay, So now we will move on to the next part, which is the Michaelis-Menten Kinetics, which is really the heart of this lecture. Okay, so we have this. Okay, so I just replaced R max with V max. So because this, if you think of it in terms of velocity, how fast is the reaction? So it will have a much, for me, this is how I understand it. So rate. I have I have trouble visualizing rate, but if we uh, rename it as velocity, so this is just an convention, so it's not really a set in stone na rules, R dapat ang isulat, but we can represent it by V, and then CS. So I just simplified it in S, diba? So CS man siya ang S. Okay. So now we'll have to how do we solve for this? Okay. So we have in Michaelis-Menten Kinetics, so we have to identify these. Okay, we have to identify these because this V and your S can be you can set this good because you can set the substrate concentration, and then that substrate concentration, you can now record the how fast the reaction is going, so V and S, you can determine them experimentally. And now, as part of identifying that enzyme, you will identify its Vmax, and then its Km. Okay? Yeah. So, how do we solve for this? Because you are not given that V or S. You are given a table. Okay? You are given a table of values. So how do you plot them, or how do you make use of them? We have linearization techniques. We have the three linearization techniques. First is the Langmuir plot. Okay, this is read as Langmuir. That's not Langmuir. I don't know how your teacher pronounced this, but this is Langmuir plot. Okay, so how do we linearize this equation? Okay, this equation can be linearized by having a reciprocal. Okay, so reciprocating this, diba? So you have 1 over V, and then you have Km plus S, then V max S. Okay, so and then multiply S to both sides, so and then you'll have S over V, and then you have Km and V max plus V max, then S. This is 1 over V max. Okay, so what do these terms represent? So in a line, diba? So this is your Y, okay, and then this is your y-intercept, your B, and then this is your slope, diba? 1 over V max is your slope, and then X is S, okay, your substrate concentration. Okay, so that's the first equation that you have to take note, diba? And then next is the Lineweaver-Burke plot. So how this is derived, it's just it's similar to how this Langmuir is plot. Langmuir plot is derived. In fact, it's just a continuation or another method for this. Okay, so it's just 1 over V, then KMS, Km plus S over V max S. Okay, so just reciprocated the two terms, and then you will have to multiply, no, uh, no, not multiply, but just separate these two terms. Okay, so you have Km V max, then 1 over S, diba? So just showing you this, so 1 over V max. Okay, that's the Lineweaver-Burke plot. So in terms of one, so this is your Y, this is your M, this is your X, and then this is your Y-intercept. Okay, lastly, we have the Eddy-Hofstee plot. So it's kind of a bit weird, in its derivation, but let's continue with Lineweaver-Burke plot. So as you can see, this, okay, so this is what they have done. Okay, so yeah, you have let's start with this, so you have 1 over V Km plus S, and then V max S. Okay, so what he did differently, okay, is that he multiplied V, then V max and Km to both sides. Okay, so yeah, that's what he did. So V max over Km, and then Km plus S, V max S. Okay, so that's what he did. Okay, so simplifying both sides, and you will have what will you have? Okay, so V max over Km, right? And then you have V over S plus V over Km. Okay, so let's simplify this, so that we will have V on the one side, and then the other terms on the V on the left side, and then the other terms on the right side. Okay, so you have the V over Km, and siya V over Km, ayan, V max over Km minus Vs, diba? Then multiply Km to both sides, so then you will have V max minus Km, then V over S. Okay, so that's the Eddy-Hofstee plot. So this is your this still the same, so but this is your M, V max is your Y-intercept, then Km is your slope, and V over S is your X. Okay, so now let's see what this look like, diba, on a plot, diba? So as you can see, Langmuir and Lineweaver-Burke is in the right, pasaka, yung slope, and then for Eddy-Hofstee plot is paubos. Okay, so it's going down. Okay, so that's how these linearization techniques look like. Okay, so let's do a sample problem. Let's do a simple problem. So from a series of batch runs, with a constant enzyme concentration, the following initial rate data were obtained as a function of initial substrate concentration. Okay, so you have your substrate concentration, which is your S, yeah, and then initial reaction rate, which is your V. Okay, then so you have to evaluate the Michaelis-Menten parameters Km and V max by employing the Langmuir plot, Lineweaver-Burke plot, and the Eddy-Hofstee plot. Okay, so you have to use the three methods. Okay, sige. So I'll just So what we have here, no? So we have to linearize, no? We have to linearize. So you have V, B, max, then you have S, Km plus S. Okay? So for linear plot, and I encourage you to do this with me, diba? So for linear plot, you have to tabulate this. So use your calculator, go to mode 3, 2. Okay, so that's the stat mode, the linear mode in your calculator. So if in X, diba? In X, you have to put the S values, diba? And then in the Y, you have to put your S over V values. Okay, and then if you get na, no, this, so you have to go for the answers, diba? So what you will have is your first, you will have your slope, diba? So slope is your M. Your slope there is 1 over V max, diba? And this is equal to 1.5866. Okay, so this is in your calculator. This is, I think, in A, diba? So just shift 1, then 2, then 1. Pagitaon ninyo ang A, because in your calculator you have shift, this is the format in your calculator. It's why A plus BX. So you have to find the A value. So if you don't know this, no, in your calculator, please tell me in the comments so that I will teach you. No, we'll make a separate video on this. Or there are many YouTubers that teach this, no, in your calculator, calculator techniques to find the slope and then your y-intercept. Okay, so A plus B, no, A plus B, X plus B. You have to find your A plus BX. So B the I, so B. So this is your slope, no, and then this is your y-intercept. So B, no, so YB plus MX. So that's how it is. So and then you will, if you get the value of your M, or your, this is the letter B, no, in your calculator, this is what it will generate, no, 1.5866. So just have to reciprocate it. So you'll have your V max, no, then you will have your V max as 0.6303. Okay, and then you have your your y-intercept, diba? Y-intercept is km, then V max. So this is letter A in your calculator, diba? Shift 1 to 1, I think. Shift 1 to 1 is siya in your calculator. So after you have stored this, no, shift 1 to 1 lang dahil. And then you will have this, so 4.6417, diba? So we have to find the km. So just multiply the value of V max to your km, then you will have this value, 2.9256. Okay, so and then you will ask me what is the unit of that. So just remember, diba, kung velocity gani, so meaning it is a concentration over time. So this is millimole per liter per minute, diba? And then this, if km gani, this is a just a concentration. Okay, so millimole per liter, millimole per liter. Okay, kung V max, it's a rate, So naa siya per minute. Okay? And then this is in first order, no, na kuan na terminology or in the system ng first order. Okay? So let's move on to kuan, no? Let's move on to um, Lineweaver Burke, no? So I'll just no? This is what you will do, 1 over S, no, in your X, and then 1 over V in your Y. Okay? So just follow, just, and then do what I did earlier, no, sa kuan kini. Just follow this, yung mga parameters, find them in your calculator, ba? And then you will kuan, I will just show you the summarized version of this later. Okay, so your ED Hofstee nga plot, ba? So EH nga plot. So what you will put in your calculator as X and Y nga mga values, ba? It's just V over S siya, and then you have your V and your Y. Okay, so just follow what I did earlier. So I will have to show you the the summary of what I have got, and then I also plotted this in Excel so that you will see, diba? So that you will see what this in practice looks like, diba? So you have your Langmuir plot, then this is the equation, no? This is the equation. I have got these two and these also. Okay, so if you were to choose, no, which one of these plots represents the best, no, in the enzyme, so just have to view the R squared. So this is not R2 hot, it's R squared, no, person's correlation coefficient squared, no? So what is the best value of this is the value that is near to the nearest to 1, diba? So we'll have to select the nearest to 1. Okay, so that's how it is. Okay, calculated. Okay, so the next problem that we will be in this lecture, no, is to derive the integrated rate law of the Michaelis-Menten Kinetics. Okay, so we'll have this. Okay, so di ba ganina we have V, diba? V max S, then Km plus S, but we know that V, diba, is the rate at which the rate of depletion of your substrate, diba? So you have to integrate this, so derive the integrated rate law. Okay, so we have this ds over dt, diba? So let's just reciprocate, and then let's just rearrange the terms, okay, so that it will work in our favor. Okay, so V max, then S, then you have ds na siya. So this is negative, then this is dt. Okay, yeah. So distribute. Okay, let's distribute everything. No, so you have km v max. So okay, that's that. You have 1 over s, and then 1 over v max, diba? And then let's enclose, so ds na siya, and then you have your dt. Okay, so distribute ds, no, to the terms B max, this is 1 over S, this ds, minus 1 over V max ds. So integrate that. This is from SO to S, and SO to S also, and then from dt, this is from TO to T. Okay, and then you will have the the answer here, diba? So Km V max. Okay, so we have ln S over SO, diba? Minus 1 over V max, then S minus SO. Okay, and then this is T and TO. Yeah. Okay, so this is the answer to the problem. So this is the integrated rate law of the Michaelis-Menten Kinetics. So it's just short, but you have to really practice this integration. Yeah. Okay. So for the problems, I will leave you this so that you can practice these items. If you manage to see this in my YouTube channel, so I'll leave the name of my YouTube channel after this, so you can answer this in the comments below. Please answer this, or if you can contact me in my Facebook, or you can consult with me. But it's much better if you comment it in the comment section, so that we can discuss about it and I can get to you very fast. Okay, so write the expression for the enzymatically catalyzed reactions, and then this is we've done this earlier, so just enumerate here, just list here. I've given examples of that, so that it will be easier for you. Okay, next is we have this situational problem. So if you imagine that you are working with your final year project study, so you are 4th year na, so that this will be relevant to you. One of the objectives in your study is to identify the key enzyme in your study. Okay, so you are carried out experiments to determine the kinetic parameters of this enzyme. So the results of the experiments show the initial rate of reaction at different substrate concentrations. So question, what are the Km and Vmax values based on this data? So indicate your answer in the table. So we did this earlier in my example. Okay, so please do that. And then after that, so you have to choose the highest r squared value, so that it will be your basis now in determining your Km. Okay, or if you what is the closest identity of the enzyme? Okay, so I've given you the enzyme Km values here, so please find this and then justify your answer. So why did you choose that? So why did you choose chymotrypsin over beta galactosidase, or threonine deaminase over carbonic anhydrase? So, and then last two, so derive the integrated rate law. So we did this earlier, just practice it. And then number 5, apply the integrated rate law. Okay, so that's it for this lecture. My YouTube channel is Findale's Chemical Engineering School. So if you have this, please subscribe to my channel, and please ring the notification bell so that you won't miss single upload. And then my reference, if you want to see this, is the Biochemical Engineering by James M. Lee. Okay, so that ends our lesson for today. I hope you enjoyed it, and please give it thumbs up, no? If you like this video, and then please leave a comment below if you're watching this on YouTube. Okay, so yeah, I really appreciate if you gave me a feedback, no? Because I will know what I have lacked in explanation, and then I can help you answer, no? Or it can help you in understanding it further. Okay, so that's it. Bye.